So what I will cover this afternoon in the next sort of 20 minutes or so is give you an overview of ocean energy, sort of how much resource we have, what type of technologies we have to exploit this, but then also looking at the benefits, going what does it do to sort of managing our overall grid system, what can it help with regard to sort of low carbon jobs, and what does that effect does that have on the overall decarbonisation of the grid. And then, as Charlotte said, finish off by looking at some examples of what the university is doing to support this low carbon sector. So first of all, how much is out there? What's the opportunity to exploit at an international level? I'm sure many of you know that approximately in excess of 70% of the Earth's surface is either covered by seas and oceans. So the potential untapped resource is enormous. And even if we were able to tap some of that, and there's been predictions about saying, okay, we could potentially have, and it's broken between wave and tidal, but I'll summate it, in excess of 30,000 terawatt hours. And if you're not a black belt in terawatt hours, that's sort of, more than half again of the entire energy demand of the planet currently. So we could supply the overall world 1.5 times over if we exported or exploited all of the resource. And of course we won't do that because it won't all be practical to export, but that's the overall opportunity that's there. Then what about the technology itself? So we've got wave and tidal technology. The first that I'll cover is tidal. This is a device from Orbital Marine Power. They're an Edinburgh-based company that we collaborate with here at the university. They have what they call here their O2 device. It is a nascent technology. It is emerging. This is the first sort of full-scale commercial prototype that they're deploying in a sort of commercial environment. Its capacity is 2 megawatts, so that gives you the opportunity that could power in excess of 2,000 homes. So really quite a large and significant device. You can see on the top screen there the people alongside it. It is extremely significant in size. And also you see it in its deployed position in the sea there. And although these look sort of very impactful when we're looking at them on the screen in front of you here, there's almost sort of no visual intrusion at all once they're several kilometres out at sea. Sticking with tidal, and another Edinburgh-based company that we collaborate is Nova Innovation. They have a much smaller device at 100 kilowatts. They have 6 of these devices deployed in an array system or sort of a tidal energy farm in the Shetland Islands, and they're currently using that to supply the local grid and sort of then decarbonising the electricity system in the Shetlands. Moving to wave power, if I said that tidal energy was an emerging technology, a nascent technology, I would say that wave energy is probably 5 years behind it. The technology there is still sort of getting design convergence and it's still being tested. And this is another Edinburgh-based company, Motion Energy. They have a 10 kilowatt prototype that's being tested currently at the Marine Energy Test Centre in Orkney, where many of the world's devices are tested. But not to think that all the devices in the world are based in Edinburgh. I've picked one example here of wave energy from Sweden. They have tested their device in Scotland, so it's been tested at the Marine Energy Centre in Orkney. They have, again, it's a smaller device of several hundred kilowatts, but they will operate them in 10 megawatt clusters, so in much bigger farms in a similar way to wind. So hopefully that's given you a flavour of the types of technologies that are out there that we're using to sort of capture that untapped resource that's available. But then, what's the benefits of doing that? How much could we deploy? So if we look at what we could do at a UK level, if we were to meet the targets for the cost of this technology set out by the European Commission in their Strategic Energy Technology Plan, which are quite modest, then we've done modelling within the university that shows that there could be up to 12 gigawatts of both wave and tidal power by 2050. And if you were to reduce that cost, then we would sort of deploy even more in the energy mix. So anywhere between sort of 5 and 10% of all the renewables that we have in the system could at least come from wave and tidal power in the future. So a really sort of, maybe, modest overall, but still a very significant part of the overall energy mix and the decarbonisation of the UK energy mix. But if we were to do that and successful in doing that, even with those modest amounts, what does that mean for overall society? So what that means in terms of financial benefit is really quite significant with regard to the number of jobs. In the case of many renewables, we're importing them from overseas. Whereas with wave and tidal power, and you can see from the number of Scottish technologies that I showed there, we really are leading the way within Scotland and the UK with this technology, and hence a very large proportion of the supply chain is based in the UK and Scotland. And so we could have anywhere between 16 and in excess of 40 billion of economic benefit to the UK economy. In order to put that in perspective, it's double the automotive, or almost 3 times the entire UK automotive sector, bigger than the entire telecom sector, and almost a third of the entire UK construction sector. So putting it in perspective, it's a very significant part of the UK economy potentially in the future. And how does that translate then to jobs? So we could have approximately 50,000 jobs by 2050 from this sector, so playing a real part in the just transition. And probably the most crucial part here is that the vast majority of these jobs will be based in coastal areas where historically these have been fragile communities at risk of depopulation. So the right jobs in the right place is the message to take away here. But thinking about sort of what does this do is, as we move towards 2050 in the overall UK energy system, we will have more and more, or hopefully we will have more and more renewables in the system as we move towards a decarbonised overall supply. So the seasonal demand, or the electricity demand in the UK, is highly seasonal. We have much higher demand in winter than we do in summer, and this grey block shows the overall profile of our electricity use in the UK. If you map wind generation onto that, then you can see it's reasonable. It's sort of windier in the winter than it is in the summer, so that's reasonable. But hopefully you can see there that and quite often there are sort of grey peaks where there aren't green peaks, and so that creates like sort of a real problem for how we balance the overall system. And if we bring in solar, it actually just makes things worse, that we have like sort of lots of solar power in the summer when we sort of don't necessarily need it, but we don't have nearly as much in the winter when we definitely need it. So what happens if we bring in wave and tidal? So we bring in tidal's cyclical, and you can sort of forecast that for hundreds of years in advance. So we can look at sort of almost like a varying base load in the middle there. So that will help for sure balance the overall system. But if we bring in wave power, then it almost matches completely. It really helps with regard to sort of matching the supply with the demand. So it's a real enabler as we have much more sort of offshore wind and onshore wind and solar in the system, then wave and tidal is a real enabler to helping balance the overall grid. And when I say helping balance the overall grid, it makes it cheaper to balance the grid, so there's a benefit to the sort of the electricity companies and the bill payer. But then there's also a huge benefit to decarbonisation, that for every sort of peak that you're sort of knocking off of these sort of spikes in demand that wave and tidal power is helping remove, that's less gas turbines being used in order to sort of meet that demand. So you're decarbonising the grid at the same time. So a real enabling benefit there. So my takeaway message for like sort of why we're interested in this sector is that as I've just described in that last slide, it is a real enabler for net zero. As we have much more intermittent renewables going into our system to meet our net zero targets, then wave and tidal power really sort of makes it easier to sort of balance the overall UK system. And at the same time, because this is a technology currently being led at UK level, and in fact I would even say at a Scottish level, it really brings those sort of high quality jobs and economic benefits, those jobs in the right place. So potentially having a big addition to a just transition as well as meeting the net zero targets. So what are we doing at the University of Edinburgh? Hopefully, I've given you an overview there of the sort of the potential and the resource and the potential benefits that we have. What are we doing at Edinburgh to help support this emerging sector? Well, first of all, we have some fantastic facilities. And first of all, I'll cover the flow wave test facility based at our King's Buildings campus. Opened in 2016, it is the most sophisticated test tank in the world for testing wave and tidal devices. So we have maybe you don't get the scale there fully, it's a 20-meter diameter pool. It's covered in wave paddles. Below the surface it has tidal turbine generating tidal flows throughout the pool. And we can generate and simulate test conditions for any site in the world at any location in the world. So all of the tidal developers and wave developers that you've seen the slides for today have all tested and de-risked their device in the flow wave test facility, as well as many, many other devices, both from UK, Europe and around the world, all make their way to Edinburgh's flow wave test facilities so that we can really de-risk the technology before it moves into those very harsh environmental offshore conditions. As well as the devices themselves, we have a brand new test facility that we've just opened earlier this year. Charlotte mentioned it in her opening speech, the Fast Blade test facility. So as well as testing the overall devices, we also have the world's first tidal blade testing system. It's based in conjunction with Babcock in Rosyth on their site at the other side of the bridge. And again, it's a world first, world leading test facility in order to de-risk that technology of tidal turbine blades before they go into those harsh conditions. And one of the things that they're exploring with developers currently is looking at, can we have a fully recyclable blade? So I'm sure they'll be very interested to speak to you, Jenny, with regard to the opportunities that there are to have a fully recyclable blade so that the life cycle assessment, as well as the overall carbon savings from the energy production, we make sure that the life cycle assessment of the actual technology is also adding to sort of the net zero goals. Then finally, this is my own group, the Policy and Innovation Group. We work predominantly not with technology development per se, but work with technology developers and governments to make sure that the innovations that Charlotte was mentioning in her opening speech are then matched with policies that can support those innovations. And so we work with companies, we work with regional governments, we work with national governments, we work with international organisations to make sure that we've got the right policies or guide them to having the right policies in the right place, at the right time, at the right levels to make sure that these innovations. So at any one time, we can have up to sort of nearly up to 20 projects running with values of around 70 million, and at any one time then maybe 200 international partners that we're dealing with across those projects. And so many of you in the room may be some of these partners in the 200, but if you're not, then hopefully you will be in the future. One of the roles that we have that Charlotte mentioned is that we represent the UK government. We represent BEIS in their role within the International Energy Agency, which brings together collaborations in the case of ocean energy across 25 countries. And I'm going to show you a short clip of what they're doing. But just to finish my part of the talk, hopefully I've been able to give you a good overview of the very significant UK and global resource that's out there, predominantly currently untapped. If tapped, then it really does help balance the UK grid and grids internationally to make sure that they can sort of reach net zero in the most efficient and effective way. There is the opportunity, if we have the right investment in our supply chain and skills and training, to make sure that there are very significant socio-economic benefits and jobs adding to sort of hopefully providing solutions to a just transition. And hopefully, either through the conversations today or later, you're able to sort of learn more about those world-leading test facilities that we have within Fastblade and Flowwave, and the opportunity to engage with some of the world-leading industrially led research that we do. So that's all that I'm going to talk about this afternoon, although I am going to finish off with a short video, because I have shown you predominantly what's happening in Scotland and in the UK. I wouldn't like you to think that this is an opportunity that's only available in the UK or within Europe. There are a large number of countries internationally. They come together in the intergovernmental organisation, the IEA Technology Collaboration Programme, of which we represent the UK in that process. And so I'm going to show you a video that lasts just for 2 or 3 minutes that hopefully sort of rounds things off with not just the UK story, but also the international story. Okay, well, thank you for indulging me in that last sort of presentation. So hopefully you feel that you've been sort of informed by the UK opportunity, and hopefully marginally inspired by that video of the international opportunity. Thank you very much.